everybody, Mr. Mack here. I thought I would help you with getting started on this challenge set for 111. We're looking at surface area and applying some equations, maybe using some quadratics. I'm looking for you to show your evidence to your solution, including any sketches, equations, showing your work, so I could see your process and your understanding. So in this problem right here, we have this cube culvert, and it's a square prism, and so culverts have this big hole in them that passes all the way through, so water can pass. And so we have this cylindrical hole in the square prism, and I want to find the surface area. So one idea about solving this is finding or creating a net. So what does the net look like for a cube? Well, it's going to be 6 squares for our net, and all the squares are congruent. So if we find the area of one square, we know that we've got 6 of them. Let's put the other one down here. And so here are my 6 squares, and they're 2 feet by 2 feet. So all of these dimensions are 2 by 2 on all of these. I just put a couple. I don't need to write them on everything. Okay, so at the moment, I know my surface area. I'm going to call this SA for surface area. I've got 6 areas of squares. Okay, well, it's not so simple as that because some other things are happening. So in this net, we have to cut out a circle. So I'll do it on this one right here. So a circle is being cut there, and so it goes through on one side and comes out the other. So I know that these two are on opposite sides, so I can use that one. So I have to, how about we shade this in? So I've got this blue here is the shaded area that we need to find, and I'm cutting out these 2 circles, right? So I have to subtract these 2 areas of the circles. Alright, so now if I can envision this figure, I have the outsides all taken care of and the circle cut out. But now if you go into the culvert, there's nothing supporting in this figure, supporting standing or seeing this interior surface. So we have to add back some more surface area because of the inside here. Now, this inside surface is being curved by the circle here. And so if I were to flatten that out, that's an oval. Let's get the right shape here. It would look like a rectangle. So this rectangle, it gets folded in the interior of this cube, and it runs the length of the cube. So it's going to run the length of the cube, and it gets folded around this circle. So this length right here is going to be the circumference of that circle, and this length is the distance through which the culvert is pushed, the hole is pushed through to the other side. So that's going to be 2 feet. So now we have to think, well, what's the circumference of a circle? The circumference is 2 pi r. And let's maybe get that blue as well. So we have to add, that's not the right blue, this one. Eventually I'll find the right, there it is. Okay, so that interior right there is the same as this interior here that gets wrapped around. Okay, so we're adding back in here this section, and that's going to be, this is length times width is our dimensions of a rectangle. Well, let's write it back this way. So area of a rectangle. And so on this step right here, we can make our substitution. So we have 6. So what's the area of a square? Okay, so the area of the square formula is s squared, where s is the length of a side. So in this case, our s is 2 feet. Okay, so we've got s squared minus 2. Okay, so what's the area equation for a circle? It is pi r squared. So we need to know what r is. So what is r in this figure? So let's go ahead and show r. That's r. And r goes from the center all the way to the edge. And we know that the entire length of the side is 2, so therefore r has to be 1. So r is 1 foot, and the area of a rectangle, let's make this look like a rectangle, is length times width. But our length and our width, let's get this in here, pi r squared goes here. Our length and our width are going to be, our width is going to be 2, and our length is actually going to be 2 pi times r. And our r is 1, so our length is going to be 2 pi times 1. So in our equation here, I'm going to put a length is 2 pi times r, and our width here is w. And so now I can substitute everything into my equation for surface area. There's a loud truck going by. So surface area equals, I got to make our substitutions and then solve, and you can get a decimal. And don't forget, our final answer for surface area is going to be feet squared. Okay, so I'm going to leave you with that, and you can get the final answer. And look, I'm showing a lot of work here, and this is my expectation for you. Okay, it's not just to get a final answer. I'm more interested in the process. Let's take a look at 2. Maybe help you set this one up. We have a rectangular prism with a width of 10. Alright, so I've got a width of 10 millimeters. The length of the prism is 2 times as long as the height. The length is 2 times the height. Okay, so if the height were to be 3, 2 times 3 would be 6. The length would be that. If the height were 5, then the length would be 10. Okay, so the surface area, so the height, we have a height dimension here. We're not giving any information about the height is, but the surface area, we're told, is 216 millimeters squared. Okay, so what is the length and the height of the prism? Alright, so we have a prism. I'm making a prism now, 3D view of it. something like that. Alright, so we have a length dimension, a width dimension, and a height dimension for this rectangular prism. And so there are going to be, so in our surface area equation, I'm just going to write the equation. Surface area equals, we have 2 length times width rectangles. So here's the length, and the width is this. Let's get something better here. We've got this base is a length times width, and this top part. Those two rectangles are congruent, have the same dimensions. So that is 2 length times widths, those areas. We have 2 length times heights. So the length and the height, so this is also the height right here, right? So it's this right side and this left side are length and height of 2 of those dimensions. And there are 2 width times height. So the width and the height would be the front rectangle and the back rectangle. Those are both going to be congruent and have the same dimension. So I have 2, 2, and 2. That's 6 sides. There are 6 sides to a prism. So I've got all my dimensions here. My variables W, L, H, and SA are defined here. And the one that I don't know is H. I don't have anything for that. So now we're just going to substitute everything into our equation. So I've got 216 equals 2 times, so length we're calling 2h. Width we know is 10 plus 2. Length is 2h. Height, we don't know it, so I'm just going to keep it as height. So we can just, height is just height. Plus 2 times width is 10 times h. And there's our equation. And if we look, we see that we only have, here's height here, and we have height here and here, and we have height here. So there's just one variable. So whenever we have one variable, we can solve for that one variable. And for this one, you're going to see this term right here is going to give us an h squared term. And then this one here is going to be an h term, and this one is going to be an h term. So this means we're going to have to put our equation in standard form. Standard form is ax squared plus bx plus c equals 0. But of course our variable is h, so it's going to be something like h squared plus h, right? And then you're going to have to factor the trinomial and find your values for h that give the quantity 0. Okay? It works out to be a nice integer. Okay, so you guys have all the format here, the organized problem ready to do a little work on your own. Okay, so this last one right here, I think 3 is actually easier in a way. It just deals with a cylinder, which is a little bit more difficult in some ways, but the math works out to be a little bit more simple. We have a cylinder, and we know that I'm just going to make a cylinder here. That the height that has a height 3 times as long as the radius. So the height is 3 times the radius. So whatever the height is, whatever the radius is, the height is going to be 3 times that. So if the radius is 10, the height would be 30. If the radius is 2, the height would be 6. The surface area of the cylinder is 200 pi meters squared. What is the radius and the height of the cylinder? So this is the radius, and this is height. We only have 2 dimensions that we need to worry about for a cylinder. Okay, so what is the equation for a cylinder? And if you're not quite sure, you can always make a net, which kind of looks like a division symbol, right? And we've got a radius, our height goes here, and this length again is going to be the circumference of this circle, which is 2 pi r. So surface area is going to be, we have 2 areas of circles plus area of the rectangle. The equation for area of a circle is pi r squared, and the area of a rectangle is length times width. Okay, however, the length of this figure here is the same as our circumference, and the width of this figure is the same as our height. So I'm just going to replace these 2 variables with length, which is 2 pi r, and width, which is h. And we know the surface area. Okay, the surface area is given. R, we don't know R. Be nice to know R. But we do have a value for h that we can substitute. So if we substitute 3r in for this h, and then we look at our problem, we will all have just the only unknown that we have in the problem is r's, and we can solve everything else. Okay, so I'm going to leave you with that. This one also works out to be a nice answer, and you'll see something happens with pi's in the problem. Alright, I'm going to leave it there, and hope that's helpful, and I look forward to seeing what you guys come up with. Alright, see y'all later. Have a good one.